Welcome to this pre-algebra tutorial on simplifying variable expressions. The goal of this tutorial is, by the end of this tutorial, you will be able to identify what a term is, what like terms are, and how to combine like terms to simplify variable expressions. So let's look at the following expression. If we remember, an expression is just a group of terms that doesn't contain an equal sign. It may contain variables, whole numbers, but it doesn't contain an equal sign. In this expression, we have coefficients and terms. Each one of these is a term. So the terms are of this expression, if I wanted to know what the terms are, they are 5x, 2x, 7, and x squared. And this term will come up all the time. Coefficient. This word will come up all the time. Coefficient. Now, let's erase the one arrow going to 7 because 7 doesn't have a coefficient. But the rest of these have a coefficient. And the coefficient is the number that's accompanying the term. So the number that accompanies the term. So my coefficient here, I'm just going to put C for coefficient. My coefficient of 5x is 5. My coefficient of 2x is 2. But what about x squared? There's no number there. But remember, in algebra, when we have a simple term with no number in front of it, the coefficient is always 1. So I put this term x squared there for just that reason. That often comes up in algebra, these terms that don't have a number in front of them. So it's important to remember, first of all, that these type of terms always have a coefficient, always have a number 1 out in front of them. So if I was to add 5x, say I had 5x squared and I had an x squared, I could add those two and become 6x squared because that x squared represents 1x squared. So that brings me to the definition of like terms. Like terms, combining like terms is one of the most basic and constant things that you will do in algebra. So it's important to know what like terms are. You have to combine them all the time, all throughout math. You're going to be combining like terms, so it's important to get a definition of those. And just a logical definition, this is more of a textbook definition. We're going to break it down into a logical definition a little bit later on. But the definition of a like term are terms that have the same power, identical variable parts, and all real numbers are like terms. And an expression is a group of terms. It's a group of terms without an equal sign. That's important. Once you put an equal sign, then you have an equation. So let's look at the following equation, group of terms. Look at the following group of terms. Of these terms, which terms are like? Well, I have 8x. We know that's not like 9y because x and y are different. We know it's not like 7 because 7 doesn't have a variable. And we know 8x and 9y and 7, are they like x squared? The closest one to 2x squared is 8x. But it's not like because it doesn't have the same power. So we cannot combine an 8x with the 2x squared. So we'll have to say none of these terms are like. Let's look at the next example. If I took 2x squared and I took 3x squared and I took 4x squared y and 27. Which of these terms are like terms? Okay, so I have 2x squared, 3x squared. They have different numbers, but they have the same exact variable terms. So these two are like terms. 4x squared y. Well, we see we have an x squared, but because of this y, it's not the same as the other two. And we know 27 is not the same as any of those. And 27 has a special name. It's called a constant. And a constant is any number. Any real number is a constant. The constant term is very important. One of the most well-known formulas that contain a constant is when we want to convert from Fahrenheit to Celsius. Fahrenheit equals 9/5 Celsius plus the constant 32 degrees. So that is a constant. No matter when you try to convert from from Fahrenheit to Celsius, you're always going to add this constant term, 32, on the end. So you try the following. We have 3y squared, 2y squared, 3.1y squared. Which are like terms? Well, they're all like terms because 3, 2, and 3.1 are all real numbers. And even though this is a decimal here, they're still like terms. They all have the same variable with the same power. So we could combine all of these, which we'll do after the next example. We could combine all of these because they all have like terms. We're all real numbers, as we said. All real numbers are like. So this would be a good time to pause the video and try the following example. We have 7, 2, 2.3, 2 squared, 2x, and 2x squared. I want you to identify the like terms. Only way we can combine like terms, which we have to do next, is if we can first identify those like terms. So, out of these, which are like terms? Pause video. If you said, I have 2, 7, 2.3, even 2 squared is a like term because 2 squared is just 4. 2 times 2 is 4. And those are my like terms. 2x and 2x squared are not like, they don't have the same power. So now let's simplify the expression using what we've just learned. So if I take 3x plus 5y plus 7x, I want to combine like terms in this expression. So if I want to combine like terms, I have to first identify the like terms. The like terms are 3x and 7x. We see they're separated. We know that from previous lessons that we can move these around. 3x plus 7x. By the associative property, we can move those around so that we can combine them. So now that we move them around, we can combine those by the associative property. That equals 3x plus 7x, 10x. And we just bring the 5y down because we can't combine it. We combined like terms and we simplified it as low as we can go, and so that's the answer. Let's look at another example. I take 4y plus 27 plus 6 minus y. Okay, I want to simplify by combining like terms. Okay, let's identify our like terms. 4y and a negative y are like. All real numbers are like. But we can regroup regroup these by the associative property. So we have 4y minus y plus 27 plus 6. So 4y minus y is just 3y. 27 plus 6, 33. So that's in simplified form. We can't go any further because 33 is not like 3y. So that's as far as we go as far as simplifying this example. So now you try. Simplify 9 plus n minus 1 plus 3n. So you try to follow an example. Let's take, I say, 8n plus 2n minus 1 plus n. Okay, pause video and try this example. We have okay, so if you said 8n, let's just use the associative property and regroup these. By the associative property, we can regroup our terms of our expression without changing their value. So now if we regroup these, we have 8 plus 2, that's 10n. Bring down the n, plus n minus 1. Well, we see we still have like terms because n and 10n are like. But how many is n? N is just 1. So 10n plus n gives us 11n minus 1. These terms are no longer like, so we say that that's completely simplified. Try another example. What if I had a more challenging example? I had 9c squared minus 2c squared plus 8c squared. Pause video and try this example. Okay, if you said all of these are like because they have the same variable. So I have 9c squared when we have the same, it's the same as operations on integrals. It's the same as operation on integers, where you take the difference of the absolute value of the terms and you bring down the sign of the larger. So that's 7c squared plus 8c squared. That equals 7 plus 8. Now you have operations on integers where you have the same sign. You just combine the absolute values of the numbers and you bring down that common sign, which is positive. But in algebra, we don't write positive signs on a single term. So that's just 15c squared and not positive 15c squared. So let's look at one more example. Let's simplify. I take x plus y plus z plus 1. First thing we look at is whether we have any like terms. So there are no like terms here. So the simplified version of this just is as it was given, x plus y plus z plus 1. Just because we have terms doesn't mean that we have like terms. So you have to watch out for that. The answer is as is when you don't have like terms. So that's another thing to look at, another thing to watch out for. So what have we learned? Definitions of like terms are terms that have the same power, identical variable parts, were all real numbers. All real numbers are like terms. An expression is a group of terms. We also learned that if we look at an expression, the terms of the expression are the individual parts. So here the terms of this expression are 5x, 2x, constant terms 7, and x squared. Our coefficients are the number that's accompanying the variable 5, 2, and out here there's a 1 that we don't see. That's the coefficient of x squared is 1. Constant term 7. And so we also learned with the given definition of like terms how to identify like terms in an expression. So in the first one we had 8x, 9y, 2x squared, and 7. And we found that there were no like terms there. 8x and 2x squared were the closest, but the powers are different. So by definition, they're not like terms. But in the second example, we did have a couple of like terms. We looked at 2x squared, 3x squared, 4x squared y, 27. And the two like terms that we had were 2x squared and 3x squared. The other two terms, 4x squared y and 27, are not like 4x squared. Y is not like 3x squared because that y makes it unlike that term. Then we simplified expressions involving like terms. So we looked at 3x plus 5y plus 7x. We regrouped those according to the associative property 3x plus 7x plus 5y. We combined the like terms. 3x and 7x gave us 10x plus 5y. In the next example we did the same thing. The only difference is we had a negative y, and so we had to remember that the coefficient of negative y is 1. So when I combine 4y to a negative y, I get 3y. Combine the real number terms. All real numbers are like, so I can combine 27 plus 6 to get 33. We tried some further examples, 8n plus 2n minus 1 plus n, and we did the same thing. We regrouped them so that we could combine them. 8n plus 2n, 10n plus n, 11n minus 1, 11n minus 1. That's in simplified form because we have no more like terms. And we did the same thing for the next example, 9c minus 2c squared plus 8c squared. And we did the following example where we had x plus y plus z plus 1. And this is in a unique example where you don't have any like terms. So the simplified form is just as is, x plus y plus z plus 1. That's simplified. So that concludes this tutorial on simplifying variable expressions. Hopefully it was helpful to you. Please like, subscribe, share, support. Thank you.